Here we have to solve for x in the given exponential equation. Okay, for that, first let's simplify the given exponential equation. Here we have -1 and here we have a constant value 5. When I add 1 to both sides, the equation can further be simplified. Okay, first let me write the given equation as it is. Okay, so I'm adding 1 to both sides. When I do so, -1 positive 1 will cancel out. I get 2 to the x power equals to 6. Okay, now we have to solve for the variable that is at exponent. So in any equation, if I want to solve for a variable that is an exponent, so I must get the same base on both sides. Once I get the same base on both sides, I can equate the exponents and I can solve for x. Here, the base on the left side is 2. So is it possible to get the same base 2 on the right side? So for that, 6 must be a power of 2. But actually 6 is not a power of 2. So I don't think we can get the same base on both sides. So then how can we solve this exponential equation? So the only option we have to solve this kind of exponential equation is using logarithm. So that is we have to take logarithm on both sides. So now in this case, I'm going to take a common logarithm on both sides. Common logarithm means a logarithm with base 10. So because when I take common logarithm on both sides, that is logarithm with base 10, I can easily get the values of common logarithm using regular calculator. Okay, now let me take logarithm with base 10 on both sides. That is log to the base 10, and here the argument is 2 to the x power, and here log 6 to the base 10. I've taken common logarithm on both sides. Now I can use the power rule of logarithm over here. Whenever the argument is exponential, the exponent and the argument can be moved in front of the logarithm, and it has to be multiplied by the logarithm. So now I can move this exponent x in front of this logarithm. In the next step, I'll be getting x times log 2 to the base 10 equals to log 6 to the base 10. Okay, now to solve for x, I have to get this log 2 to the base 10. For that, I have to divide both sides by log 2 to the base 10. So log 2 to the base 10. Okay, this log 2 to the base 10, log 2 to the base 10 will cancel out. I get x equals to log 6 to the base 10 divided by log 2 to the base 10. So here on the right side, we have division of two logarithms, and for both the logarithms, we have the base 10, that means common logarithm. So we can get the value of log 6 to the base 10, log 2 to the base 10 using our calculator. So if I get the value of log 6 to the base 10 using our calculator, I'll be getting 0.7782. So even after this one, I have some digits, but I have rounded the value of log 6 to the base 10 to 4 decimal places. Okay, now I'm going to get the value of log 2 to the base 10 in denominator. So its value is 0.3010. So here also I have rounded the value of log 2 to the base 10 to 4 decimal places. Okay, now we have to divide 0.7782 by 0.3010. So when I divide, so I'll be getting 2.5853, and it keeps going. So if I round this value to the nearest hundredth, it will be 2.59. So because the thousands place we have 5. So whenever we round it to nearest hundredth, we have to look at the digit at the thousands place. So if it is 5 or greater than 5, we just have to add 1 to the digit at the hundredth place, and we have to ignore the rest of the digits. Okay, so the approximate value of x in the given exponential equation is 2.59.